In this video, you're going to be given a Great Submission API service that you can deploy in your Kubernetes cluster. And we're going to set up a Kong Ingress Controller, which can provide external access to this Great Submission API service to a bunch of end users. Now, Kong isn't just an ingress controller, it's actually a very powerful API management tool because what we can do is set up our Kong API gateway to ensure that only authenticated requests can actually reach our Great Submission API service, only requests that have the correct API key. And furthermore, what we can also do with this Kong API management tool is ensure that authenticated clients can only make a certain amount of requests per minute. So we're going to use Kong to expose our app to the outside world, secure access to it, and prevent users from making too many requests to it. Very exciting video. All the starter code will be provided, so let's just go ahead and get started. Inside of your video description, I left you a link to a GitHub repository that contains all of the starter code, as well as templates that we're going to use throughout this video. So really important that you go to this Git repo. All right. And once you do, feel free to clone it into a directory of your choice. Doesn't really matter. Anywhere where you can have ease of access to it. Once you clone the repo, we're going to load it into whatever editor you like. I like using Visual Studio Code. And here, looking at the starter project, we have a namespace called Great Demo, where a Great Submission API is going to be deployed, serving requests on its container port 3000, which can be accessed through the following cluster IP service. So let's just go ahead and apply everything just to get started and make sure that everything is functional. So kubectl apply-f, we're going to apply everything inside of the current directory using a dot. All right, and everything gets created. Everything looks good. Let's go ahead and say kubectl get pods-n grade demo to make sure that all the pods are functional. They are. Kubectl get service-n grade demo cluster IP service that we can use to access our pod has been deployed. So what we're going to do is forward this internal port to a port on our machine. We can do that using the familiar port forward command. kubectl port forward the following services internal port 3000 to a node port 3000. And this is all happening inside of the namespace grade demo. All right. And now what I'm going to do is make some requests to our Great Submission API. So the Great Submission API accepts GET requests on the root path, but doesn't really send back any data, just says cannot get. So if we go back to the following, here we have some commands that we can use to make requests. Windows users, if you want to run these commands, make sure that you use git bash, or if you decide to use PowerShell or the Windows command prompt or whatever, then you'll have to adjust these commands accordingly. Okay. So I'm going to go ahead and obviously it's not going to process this stuff, but it will process all of our curl commands. The fact that we get any output means that all of these curl commands worked. Here it submitted a grade for Harry, Ron, and Hermione, and then it retrieved all the grades. All right, very cool. So everything is working smoothly, but there's a problem in that we needed to port forward the service's Great Submission API to our local machine port in order to be able to access it. If this was running in prod, then port forwarding wouldn't really be possible nor feasible, all right? We need an external endpoint by which this Great Submission API can be reached, an ingress controller that can act as a reverse proxy and get all of the external traffic from end users and somehow redirect them to our Great Submission API. Now, Kong isn't just a reverse proxy. It's also an API management tool. So many of you are probably familiar with the Nginx Ingress Controller, which is essentially just a reverse proxy, but Kong, what it can also do is apply authentication. So any requests that come externally, it can actually check if they have a valid API key to access the Great Submission API. What it can also do is apply rate limiting. So if a client has made more than X amount of requests per minute to the Great Submission API, it can stop them from doing so, which can effectively help prevent DDoS attacks. So you can think of a mere ingress controller as just a door, but an API management tool like Kong as a door, but also a bouncer that's standing in front of it. Okay, so the first thing we want to do is start by installing Kong. All right. And the way to do that is to use a Helm chart. So this Helm repository contains 3 Helm charts, one of which we need to download called Kong. So the first step is to add this Helm repo into our local Helm configuration. If you don't have Helm installed, I left you a link inside of the video description that you can use to install Helm. If you're not familiar with Helm, highly recommend you check out our Kubernetes training course. Link for that is inside the description. But anyways, I'm just going to go ahead and start by adding this repository, which I'm going to give it an alias of Kong. You can give it whatever alias you want, but it usually should be something practical. And we're going to add the following Helm repo. I already had it, so it says it already exists. And now what I'm going to do is search this repo, Helm search repo Kong. And within the Kong repository, there are 3 Helm charts, okay? There's the Helm chart for Kong, a Helm chart for the gateway operator, and a Helm chart for Ingress. The Helm chart we want to install is the one for Kong. Let's go ahead and install this Helm chart. I'm going to call the Helm release Kong. So basically what this means, the contents of this Helm chart, we're going to release all of it into some namespace. All right, so now we need to refer to the Helm chart itself, which is inside of the Helm repository Kong. The Helm chart itself is called Kong, and I'm going to release the contents of this Helm chart under this name inside of the namespace Kong. This namespace hasn't already been created, so let me create it on the fly using the create namespace flag. And you'll notice here that there is a chart version for me. Depending on when you're watching this video, the chart version may be different. Just so that you're consistent with me, I'm going to hard code the version to be 2.47.0. I recommend that you use the same version as myself. All right, and now what I'm going to do is modify this installation before I go along with it. Because if you took my Kubernetes course, you'll know that a Helm chart is just a bunch of Kubernetes manifests, YAML files, a bunch of templates whose values are filled in by whatever is defined inside of a values.yaml file. All of these default values are good for our purposes. The one that we need to change so that we can continue with this tutorial is proxy type, which is currently set to load balancer. So if your Kubernetes cluster is hosted on AWS or Google Cloud, you should actually leave this value and not touch it, because what you would have is a load balancer sitting on the edge of your Kubernetes cluster, ready to receive all of the external traffic and balance the load across your Kubernetes services. And so by setting proxy type load balancer, what it does is it configures your load balancer to automatically redirect all that traffic to the Kong Ingress Controller. And then the Kong Ingress Controller from there is going to, based on its routing rules, decide where to forward traffic and what authentication mechanisms to apply to it. All right, but I'm not running my Kubernetes cluster on AWS or Google Cloud or whatever. I'm running it currently inside of Docker Desktop inside of my local machine. If you're running Kubernetes inside of Minikube, Docker Desktop, or whatever on your local machine, you don't have a load balancer. You're simply going to make requests like me through your localhost node port 3000. Okay, so we need to set this to node port. But if your cluster is indeed on AWS or Google Cloud or whatever, then you don't need to modify this value. You can leave it as a load balancer. But in my case, I need to set it. I need to set the proxy.type inside of the default values.yaml file equal to node port. Because ultimately, whenever I make requests on my node's port, whatever that may be, localhost, I don't know, 31,000, I want that request to be redirected to my Kong Ingress Controller. So I need to specify that. And another thing that I usually like to set is env.database is equal to auth. So let me check this field just to show you and allow you to have reference to it. Database. Oh, it's already set to off, which is good. So there are two modes, on or off. On means the configuration will be loaded in from a database, which I'm pretty sure is PostgreSQL. Off means the configuration will be loaded in memory based on whatever configuration files we define, which would be a lot easier and is the recommended approach. So we don't really need to write this because the default's already off, but we already wrote it. It won't hurt. All right, sweet. Kong was deployed. Here it's giving us a bunch of commands that we can use to get started, but before we do anything, what I want to do is make sure that everything was successful. So get pods-n Kong. It crashes for a bit. It's restarting. It should work. I think it's just initializing and setting up. So let me just make sure. It's running at the moment, but the pods aren't exactly ready yet. So while this is happening, I'm going to say kubectl get service-n Kong. And this is what I want to point you to. So if you, when performing your Helm installation, if you didn't modify this, this would have said load balancer, meaning that our Kong proxy service would have been ready to receive traffic from whatever load balancer is inside of your Kubernetes cluster. It does some Kubernetes magic behind the scenes and knows how to configure it such that whatever traffic comes in through your load balancer as a port will be redirected to Kong's either its HTTP port or its HTTPS port, depending on which load balancer port was used. But in this case, we're using node port. So whatever request that I make through localhost, in this case 30,664 or 30,589, will be redirected to Kong's internal 80 port or 443 port, okay? So if I try to make a request to this right now, I'm not really going to get anything because it's going to be redirected to the Kong Ingress controller, but it's not really going to know what to do with it, right? It's just going to say no route matched with those values. And that's exactly what we want to get started. So let's go ahead and implement those routing rules right now. Inside of your GitHub repository, which I linked you to in the very beginning, what I want you to do is copy the following ingress resource into a file, which I'm going to call O3 Kong Ingress.yaml. All right, go ahead and paste it. And let's unpack this. All right, so the first thing I'm going to do is call this, I don't know, great submission. Keep it consistent with our great submission API. And I'm going to deploy this inside of the same namespace as where everything else is being deployed. I'll explain what strip path is in just a second. Plugins, we're not going to configure at the moment. Inside here, we are defining the ingress class name. All right, so you can have many types of ingress controllers, inside of your cluster. You could have an Nginx Ingress Controller. You could have a Kong Ingress Controller. Here, we're defining which Ingress Controller our Ingress resource is going to be applying its rules to. All right. And here we define the methods that are permitted to be made to our Kong Ingress controller. So get requests and post requests are allowed. If you want to make put requests and delete requests, then you would just have to add them accordingly. We're just going to leave it at get and post. And when this ingress resource is applied to our Kong Ingress controller, it's going to tell it, okay, whatever requests are made on the path slash, then what you need to do is route those requests to the service named grade submission API on port 3000. So ultimately, our ingress controller, which is now is exposed to the outside world, is going to be able to route external traffic to our service named Grade Submission API and redirect that traffic to the port where our application is serving requests. And we've essentially exposed our application to the outside world. All right, so let's go ahead and apply what we've got so far. So kubectl apply -f will apply everything. All right, we'll remake that request to, what was it? Localhost 30664 on the empty path slash. And we get exactly what we're supposed to get. It was effectively able to receive a request from the outside world on our local machine, on our nodes port 30,664, and reroute that request to our Grade Submission API service, which was processed by our pod and sent back a response. Now, this would work the exact same way if Kong was installed to configure a load balancer, such that when a request was made to that load balancer, it would redirect that request to the ingress controller and using the exact same ingress resource, reroute that request to your Grade Submission API service. All right, and now because the Grade Submission API doesn't really have any get methods that are actually serving back a proper response over here, we're going to make sure that we don't include it in our ingress resource, and we're going to say /grades, okay? Any requests made on the path /grades with this prefix, we want to reroute to the Grade Submission API. So let me go ahead and reapply this, kubectl apply -f. Everything works beautifully. Now, it only expects paths that start with /grades. So any path that starts with this prefix, it's going to send over to our API service, reroute it to the deployment. So that should work out beautifully. If I try to submit a grade, like, let me just grab all of those. Everything should work. We're not using localhost port 3000. We're using, in my case, 30,664. Yours is going to be different depending on what your service gave you. So let me just open my notes. This is kind of dirty, but whatever. What was it? 30,664. We don't need those. We don't need those. Okay, good enough. Everything works beautifully. The post requests work as well because we've allowed our ingress to process both get and post requests. If I try to make a request on the empty path slash, that's not going to work because there's no routing rule for it. The request has to start with the prefix /grades for it to work. Hey guys, sorry to interrupt. This is Rayanne, 20 minutes into the recording. I just realized that I forgot to explain what strip path is, so don't mind all of this stuff for now. It gets eventually explained throughout the video, but let's just focus on that. So strip path, what it means is it will take the prefix, remove it from the URL endpoint, and then forward that to the Great Submission API. The reason we set it to false is we don't want it to do that, okay? So whatever request I make to localhost, whatever the node port is, /grades, I want this path to be preserved in order for it to reach the Great Submission API, which is expecting get and post requests made on the following path. Now, if for some reason you wanted the Kong Ingress Controller to only recognize requests made on the path /API, such that instead of saying /grade, you said you had to say /API/grade, then in this case, what it would do, if you set this to true, is it would remove the API prefix, which is what we want, and then only this path would be forwarded to the Grade Submission API. All right, but we're not gonna set a fixed path by which all of our requests will be made. We're gonna make our requests directly on the paths that our Great Submission API is expecting, so we leave this to false, okay? So sorry for the interruption. Let's continue with the lesson. All right, beautiful. Now there is one more thing. The problem is our client is able to make these requests without providing any authentication credentials. And that's not very good. We want to secure our APIs using our Kong Ingress Controller API gateway. All right, so another thing we need to do is add a plugin that configures our Ingress Controller to perform authentication. So the Kong plugin we're going to add is the following. So O4 Kong auth plugin.yaml. All right. This plugin I'm going to call grade auth will be deployed inside of the namespace grade demo. And this specifies that we're going to use the readily available plugin called key-auth, which essentially ensures that when a user makes a request that's received by the Kong Ingress Controller, it needs to include an API key. And that API key needs to be valid in order for that request to be authorized. Okay? This defines the header name that they need to include within their request. It could be API key, it could be secret key, whatever. We're going to use the API key, just to keep things simple. And so once we install this plugin, our Ingress controller will now have the capability of authorizing requests or not authorizing them. And the way to link our Ingress controller to this plugin is to simply copy the plugin name over here to the list of plugins. All right, so the auth plugin name is grade auth. This one I'm going to keep commented out for now. Well, let's just delete it for now. We'll add it later. And that's pretty much it. So now we have the capability of authorizing users, but we need to actually implement it. So authorization is done at the level of each consumer, and that consumer is going to reference a secret that contains the actual API key value that they need to include in each request. So let's go ahead and start by defining a Kong consumer. So O5 Kong consumer.yaml. Paste that in. In this case, the consumer name, I'm going to call, let's say, Great Submission Consumer. Inside of the namespace, grade demo. Username, the username for this consumer, it doesn't really matter in this case because it's not like we're going to have a portal where these consumers or whatever organizations are going to be using to log in using some username. So I'm just going to call the username Great Submission. Custom ID, again, doesn't really matter because it's not like we have a portal that they can log in with these credentials. You may feel free to look into the Kong Enterprise license for these types of things. But anyways, what's important to us here is the credentials, which will reference a particular secret. I'm going to call it user1 API key. Okay, so for this particular user, all right, the credentials that they will need will be defined inside of the following secret. So the last thing we need to define is this secret right over here. So I'm going to say 06 Kong secret.yaml. And here, the secret name needs to match the credentials that this user relies on to make requests. So user1 API key inside of the namespace grade demo. This label is needed in order for this to be recognized as Kong key-auth credentials. All right, and now the Kong cred type again is key-auth. This label as well, and they're both set to key-auth. And here we actually specify the API key that they're going to need to include in order for authentication to work. Let's just use your secret key. Doesn't really matter. So if they include this value, your secret key, inside of a request, everything should work. I'm just trying to be consistent with what we have over here so that we can directly copy and paste it. All right, and that's pretty much it. Let's go ahead and test everything out. So we'll say kubectl apply -f everything. And now what I'm going to do is try to make requests without including any API keys or whatever. So if we try to make all these requests, no API key found in request because now our Ingress controller is configured to check for API keys. And authentication is done at the level of each consumer. Here we have one consumer that we defined, which has the following credentials. So here we created some organization and account that they can use in order to make valid requests. So let's just go ahead and copy the following command. So the port for me is 30,664. All right. Here is the API key they need to include in the header based on what we defined over here. That's the key name. The key value that this particular consumer is going to need is called your secret key. So the auth plugin defines the key name. And here you can have many, many consumers with many, many secrets, all of whom have a particular value that they need to authenticate with. So our consumer one relies on this value for authentication, and everything should work out accordingly. All right, 30,664, your secret key, it's already there. Can you remove that? Can you remove that? Make the following requests unauthorized. You know what? Let me just try something out. I'm going to give each thing its own annotation to ensure that it gets picked up. I don't believe I need to apply it everywhere, but just for the sake of it working, we'll go ahead and do that. Annotations. I don't know why the indentation is so bad. I think copying it from the Git repo isn't ideal. You can feel free to reformat it better afterwards, but let me just make sure. Files in line with namespace, same amount of indentation, we're good. kubectl apply -f everything. All right. Make sure everything got picked up. We'll try these out now. Let's just start with the post request. Beautiful. All right. The following. Beautiful. So now, not only do we have an ingress controller that provides external access to our Great Submission API service, it's able to authenticate that request as well, making sure that they have the proper API key credentials before authorizing them to make that request. So we've essentially provided external access to our API and secured access to our API. And we're going to take it one more step further. We're going to apply rate limits. Okay. So, where was it? Now we can add another plugin called rate limiting. And that one is really, really easy to set up. So, 07 Kong rate plugin.yaml. I'm just going to copy the following. Sorry, making sure I copy it right over here. And before I forget, adding the following annotation. So the rate limit plugin name, I'm just going to call grade limit, grade rate limit, or whatever. Same namespace as everything else. Requests by minute, we're going to say that the user, each consumer is only allowed to make 5 requests per minute. All right, so if consumer 2 makes 3 requests in 1 minute, it won't affect consumers 1's ability to make however many requests they need to make per minute. So it's really cool that we can split what requests are made on a consumer basis. All right, so we've only defined one consumer, but we can make many, many consumers. In this case, we're applying this rate limit on the one consumer that we have using the plugin called Rate Limiting, another free plugin that's offered by Kong. So now we can reference the name of our Kong plugin over here to make sure that it actually gets picked up. All right. And let's go ahead and just apply it. So kubectl apply -f, the following. Okay. And let's go ahead and make this request, but try to make it more than 5 times in the same minute. So 1, wait, is this 2, 3, 4, 5, 6, API rate limit exceeded. And that's it. You are able to provide external access to your Great Submission API service using a Kong Ingress Controller. You are able to secure access to your Kubernetes API service by ensuring that only certain consumers can actually be authorized to make these requests based on the specified API keys. And you are able to ensure that each consumer is only allowed to make a certain amount of requests per minute to ensure that your service doesn't receive too much load. That's it for the Kong API management platform that can be used on Kubernetes. If you enjoyed this tutorial, please make sure to subscribe to stay tuned with all of my DevOps content, and I will see you in the next one.